Hey guys, welcome to week 5 of the course. So we're just gonna be going over some stuff. So let's go to the next slide. So the topics that we're going to cover in this overview is going to be sessions and view states, the data access layer and repositories within your application, business logic layer within your application, web API architecture, so kind of like how to architect your API to make it more scalable, and your application in general using the data access layer, repositories, and business logic layer, and how interfaces play a role in all of this. So let's go to the next slide. So sessions and view states. So sessions are a way to store information about a user's current session on the server. So let's say you log in into a website, then your information is going to be stored as a session. So then whenever you log in, the website then now has information about you and can show that information about you on different web pages throughout your experience on that website for that one session. So as I said, it's available throughout all the pages within the application, and it's used to store information that is utilized throughout the entire application. So user information, whenever you log in, stores your name, your last name, maybe your address information and all that stuff. And all that stuff can then be later used throughout the entire application to greet you by name, or do any other things. So for instance, this session, if you log in, it makes a query to the database saying, hey, this user with this email and this password is trying to log in. Give me back the user information. So then the database sends back the user information, and then the application in the back end stores that user information into the session. So a session is stored until the session is killed by the application. So for instance, you have a logout button, right? So when you click it, you want to abandon that session. The session is destroyed when the browser is closed or when the session expires. So you can set the different expirations for the sessions in your web config. So view states. View states are very similar to sessions, but they have differences too. So view states are stored as hidden fields on the page. So view states are actually stored. Sessions are stored on the back end on the server. View states are stored on the front end on the client inside the browser as hidden fields. And unlike sessions, view states are only accessible on one page. So whenever you set a view state, that views on a page, that view state is only available on that one page and on no other pages. But they still act the same as a session, as in it stores information that you want. And the more view states that you have, the issue with that is it lowers the performance of your page, because if you store big stuff into a view state, like, I don't know, a list of 1 million customers, for instance, that's a lot of customers. I don't know why you'd be storing that information in a view state, or why you would be loading that much information. But let's say that you did do that. That would put a lot of data stored onto that one page. So instead of your page taking, let's say, 1 second to load, it might take it 10 seconds, 20 seconds to load, and that's a pretty bad user experience. So think about what you're storing into the view states if you do use it, and try to maintain that information and that data that you store into least amount of data as possible. And a view state is stored until the browser is closed or until another page is loaded. So let's go and talk about the data access layer and repositories. So with the data access layer and the repositories, you can connect directly to the data storage and perform create, read, update, and delete operations. So what the data access layer and repositories do is they allow you to access the data directly. They can call a stored procedure. They can do inline queries. If you're using Entity Framework, you can use DB context within these. Usually, if you're using Entity Framework, though, you're only using a repository. You most likely don't have a data access layer. But anyway, you would use a DB context to make queries to your database. You can have both a repository. You can have only a repository, which is pretty common for Entity Framework, or you can have a repository and data access layer. Whenever I don't do things in Entity Framework, I like to create a data access layer just to give me another layer of separation. If you have both, you would use the data access layer to retrieve and convert the data that you retrieve from the database to models. And you would use the repository to be the middle layer between your business logic and your data logic layer. And I'll show you guys an example of this later on in the slides of the different layers. If you have only a repository, like I said, that this is usually only for, Entity Framework. And you'd be accessing your data by using Entity Framework's DB context. And the class is responsible for the interaction with the database, the repository. Let's see. So I'm probably going to get a little ahead of myself here, but let's say that you had a data access layer and a repository. You would use the data access layer to access the database and convert your models, convert them to models, convert the data to models. And your repository would be the middle layer between your business logic and your data layer, your data access layer. And it would tunnel things through to your business layer. And then your business layer, logic layer, would access your repository without caring where the repository is getting this data from. And just knowing that the repository will do the job of returning the models from a data source that the business logic layer needs. If, let's say, you switch to using Entity Framework, then you wouldn't need the data access layer, and you can easily swap out your repository that is utilizing the data access layer with another repository that implements the same interface and utilize Entity Framework instead. So that's the power of the interfaces. You ensure that you still maintain the same functions throughout your repository in case you ever want to switch out where you access data from. So let's continue. Oh, and if you were using dependency injection, this would be an easy swap because you would just swap the different repository within the dependency injection. So it would actually be really easy to do this swap, and it would take minimal effort if you decided to use a different data source. Benefits of having a repository layer. It's being able to mock your data for unit tests without having to hit the database for it. It allows for a clean architecture of your project. So everything that we're talking about here, all these different layers are to maintain a scalable and architecture and maintain separation of all these different layers. So each thing does a specific job. Each of these layers do a specific job, and you don't want to mix those jobs up. That way, when it comes time to fixing things, it's very easy to understand where it is. And it can contain some logic if you need to modify the model in any way before you send it to the next stage, which is the business layer, which does business logic. So now let's talk about the business logic layer. So the purpose of this is to access your repository and return a model, to return a model. And what the business logic layer does is it performs different functions or different things to the models. Like it populates them with stuff or removes stuff from them. Like, I don't know, let's say that you were wanting to send data back to the user, to the UI, and you wanted to sanitize data before you pass it down to the UI just in case. So let's say you have a user's model and you don't want to send that user's model to with the password, with the user's password, back to the user interface. So what you could have the user, the business logic layer do is wipe out that password property within that user model. Or if let's say the user selected multiple checkboxes. Let's say you had a bunch of orders, right? And you have an order model. And the user was able to select a bunch of checkboxes to select all these different orders. And they click complete, a button that says complete these orders. What you could do is you can pass that list of orders that user selected to the backend, and then to the business logic from there. What the business logic can do is it can accept a list of those orders and then set the completed date for all of them to whatever date you want it to be, probably to now, to the time that the user entered, clicked the complete button, and then ship that off to the database to update the database. And so you performed logic within that business logic layer. And you can do a lot of other different things, model manipulation and stuff like that if you need to within this layer. So, and it removes the necessity to perform business logic in your controllers or your web forms backend, as all of this logic is done there. And here's an example of what the layers kind of look like. We have the presentation layer, which is the UI. So in our instance, this is like our ASPX pages. If the front end was, let's say, an Angular app, then that app would be the presentation layer. Then we also have the API layer that sits between the presentation layer and the business layer. The API layer contains the controllers that the presentation layer interacts with. So this layer has minimal functionality, and it's just used to as a means to for the presentation layer to have access to our data. And the API layer just transfers the responsibility of the work to the business layer. So really, the API's layer responsibility is just to be there. For the presentation layer, like for events that, let's say that a user clicked a button on the UI, that button click would be sent to the API layer, and the API layer wouldn't do anything with that data. It would just route it to the correct business layer function. So, and then after the business layer, we have the data access layer. This is where the DAL layer is, as well as the repository, and then you have the data store right underneath it. So this can be like a database, a file, whatever, some sort of data store. And this is kind of like how you want to architect your APIs and just your applications in general, because this just helps separate things out and just makes things a lot more scalable and readable. So it's used as a means for creating front-end code to access your back-end code and data, and making the front-end and back-end independent from one another. So when you split things up like this, things don't depend on each other. Like you don't have everything all under the ASPX page doing all this logic in there. Because let's say that you wanted to do the same logic in another ASPX page. Well, now you have to copy and paste that code from the ASPX page onto the other ASPX page, And then if things start changing, like then they may not match anymore, the two functions. So having things behind all these different layers is gonna unify essentially this whole process. And then the data, so these are just, the the different layers. You have data access layer, you have repositories, controllers, business logic layer. So you can create one API for your application if you choose. Or you can create, multiple APIs for your application. So these are called microservices. So let's say that you wanted to, so this is all talking about the API layer, by the way. So let's say that you had one application. You can have all these different API layers that would be controllers in a web API, and any request. So like, let's say for an order, you could have all that within one API, within one controller, or different controllers, but within one project. And so when it comes time to deploy, you just deploy one project, and then all these presentation layers, the front end code just hits one server for this interaction. So that's doing it in one API for your application. Or you can create the multiple APIs like I mentioned, which are called microservices. And these are, so for instance, you can have an orders API, users API, invoices API. So what this means is each API is its own project. So what it really means is, and each project can either hit one database, or they can have their own separate databases. So it gets very complex, this architecture, but just know about it, know that it's there. And so for an example, let's say that you have a presentation layer, you have an app, an Angular app, or an ASPX application, a web forms application, and you wanted to do something with an order. You would hit the orders API, so you would hit that server for the orders API, and that would do interactions with the order, and it would hit other APIs internally if it needed to. And then the same thing with the users. Let's say you logged in, you would hit the users API, the user server, which is separate from the order server, and you would do those interactions with that API. And that API might hit other APIs, like a sessions API, internally, behind the scenes. So yeah, and it makes these APIs, it makes your application a lot smaller and more maintainable by doing this. But it also makes it, you have more projects to maintain, so code is kind of more everywhere. So it has pros and cons. And then web API architecture. So what you use to communicate with an API is HTTP verbs such as get, post, put, and delete. What these things are just methods that allow the front end code to communicate with the controllers or with the back end code. And so a get, for instance, will do selects from a database or whatever. A post is used to create or insert data into a database. A put is used to modify data from a database, so update. And delete, it does what it does is deletes things from a database. And you can, so in web APIs, you can return things in XML or JSON format. There's my mouse. Okay. And then interfaces and interface inheritance. So what this does is if you put your repositories and your business logic layers and different things, and you implement them using interfaces, it makes your code unit testable, and it enforces methods that your classes will implement. So it makes swapping out repositories a lot easier as well. So yeah, so use interfaces because you want your code to be unit testable, and the way that's done is through interfaces. So let's look at some quick examples of some of this stuff. All right, so here we are with our application. So I'm just going to walk you guys through some of the things that we just spoke about. I'm not going to go into too much detail about it, but I'm going to go enough so that you guys understand. If you guys want to watch me utilize everything that we have done, that we went over in this PowerPoint presentation, I created a video demonstrating all of this and kind of walking it through while I coded my own application. So this is very good if you want to just follow along. So I have a little list here of things that I want to cover. So let's just get right into it. So ViewStates. Actually, let's start with sessions. So I want to show you guys how to create a session and like how that transfers from page to page. So let's go into my login page here, and you will see here that you know what? Let's first start with the data access layer, repositories, and the business logic layer first, because that'll make more sense. So the data access layer, you can see here that I created a folder called DAL. And I have two classes right now in there. I have user DAL and order DAL classes. These are static classes, so if we go to them, you can see static class, and they contain static methods. This is an object. They contain static methods. And same with this one. Static method, and then I believe it's just a static object in a static class. And this isn't behind an interface because this layer isn't really gonna need it. You could have it behind an interface if you want, though, but I'm not gonna do that. And just know that I have some mock data here. For example, I have a list of users. Just for mocking data. And here I have two functions. I have a function that will allow me to get users, and I have a function here that will allow me to create a user. So, in reality, once we start implementing our database, this will hit our database instead of going in here and hitting up our static object here. So in reality, this will hit up our database and then get the user. But for now, we have it just returning the first user from this list that matches the email provided along with a password. So where x equals email, x.email equals the email provided, and x.password equals the password provided. And x just means one item within this list, so a user within this list. So x just means a user. And this is link lambda expressions, just in case you guys are interested. And then I have for each, you guys will see that for each data access layer class, for each class, I have a model for it. So you'll see that I named this data access layer user.cal.cs. I named it after user. So I have a model called user, so I named this user and then data access layer. So I have this user data access layer. I did the same thing here with my orders. It just returns a list of orders, of all the orders, and that's this list right here. And then within that, by the way, this is what my user looks like, my user's model. So we went over the user's data access layer. So then what accesses this? The thing that accesses it is the repository. So then I went ahead and I created an iUser repository class interface. And here you can see that I have an interface called iUser repository, and it has two methods within it. It has the get user, which returns a user, and then it has a create user, and it returns a user. So presumably, after the user is created in the database, it will return this. And the thing that implements this is this user repository. Again, the naming is just off of my model. So I named this repository user repository because I have a model called user. And I named this interface iUser repository because I have a user model. And the I right here is to signify that it's an interface. And so here I have the user repository class implementing the iUser repository interface. And so let's just comment this out real quick. And you'll see that it's yelling at me because I'm not implementing all the methods that the interface is telling me to implement. So then I will implement the method, and then here we go. But I've already implemented it, so yeah, let me just Control Z. There we go. So great. Okay, so now we can see here that the repository, the interface is forcing me to have a way to create a user and a way to get a user. And so then I can implement that whatever way I want. And so I'm using the user data access layer. And since it's a static class with static methods, I can just call it directly like this, user del, and then dot, and then I have my get user, create user here. And then I just pass it the function. And then let's press F12 and go into it. You can see here that, it's executing this function, which will be replaced by, database queries later on. So you can see that our repository is accessing the user data access layer, which is accessing the database. Great. So now what's accessing the repository? So for that, we have the business logic layer. So here, again, we have an interfaces folder that contains our interfaces. And we have within this BLL folder, we have the BLL classes. So if we go into the BLL class, you'll see here that we have a private read-only iUser repository and then underscore iUser repository. We have a constructor here that initializes that repository. And because this is global, now we're able to utilize this user repository here without having to, create a new instance of this class every single time that we want to use the function. And so, same thing here. We have an interface for iUser BLL, and it has two functions, again, get user and create user. And this is pretty simple. It implements, this user BLL implements the iUser BLL, the interface. So it's forcing us to create these two methods. And then we create these two methods and we just utilize the repository to do it. And then let's say that we wanted to swap out to another repository. This would be easier with dependency injection. I think that we can do this using the global.asax file for this to kind of simulate dependency injection, or we can download some NuGet packages for it. But anyway, this would be easier with dependency injection. But let's say that you did swap out to use a repository and you wanted to get it, I don't know, from a different database or whatever. You would do user repository, I don't know, you would name it 2 or be more specific about it. And then that's it. And then now all these will still do the same type of functions that you want. This will still create a user and this will still get a user. And you don't have to change anything with these names because it's implementing the interface, the same interface. So then that's great. Let's go into our order BLL, for example. So here we have, some business logic. So in my application, I want to know how much money was collected, and the way that you determine that is by the service date. If the service date has already passed, then that money has technically been collected, according to the logic of my application. And so we have a function here, in our order BLL that gets a list of all the orders, and then it goes through all of the orders and it does some business logic in order to get that money collected. And then the function utilizing this order BLL can just call this function and not care about how it's getting this information. So let's go into our order services page, and we'll see how this function is actually being addressed. Actually, it's in our dashboard. So in our dashboard, we have, money collected. We have some, a literal that gets replaced with the amount of money collected on the page load. So on the page load, it calls this function set page data, and if we go down here, we see that the literal of money collected gets set by calling this order BLL get money collected and then toString. And so now the get money collected, before I had a function here, called private decimal, get money collected. And you don't want to have all this business logic within your ASPX pages, because if you ever need to reuse this function, you're going to need to copy and paste it, and that's pretty bad, because then if it ever changes, if the way that you get your money ever changes and you miss one spot, and like let's say you copy and paste it to multiple pages, and then you end up changing it and you miss one spot, then your logic is going to be all over the place, and it's not going to be good. So having it behind this unit of work, this BLL class, only makes you change it in one place. And the way that we utilize this BLL class within our ASPX page is we create a read-only BLL class, and we instantiate it here. And then we can use this global underscore order BLL throughout our entire application if we want. Yeah, and you can see here that, when we go into this function, it's utilizing our BLL. So let's go ahead and delete. I guess I already did. Okay. Okay, so we went over business logic layer, repository, and data access layer, and you can see like how this is more maintainable by doing all these different layers and minimizing the unit of work that these different layers need to do. Makes your project a lot more maintainable if it ever becomes big. Now, for a smaller project, does this really matter? Not really, but it's good practice to do anyway, because it just makes your project more maintainable. So now that we understand how this works, let's go ahead into sessions real quick. So in my login screen, whenever someone clicks the login button after they enter in information, it goes into the user BLL class that I initiated up here, and It gets the user based on the information that the user typed. So if there exists a user with the email and password that the person typed in, we'll get a user. If it doesn't match, this will return null. So if it doesn't return null, which means that we did get a user, then this is how we set the session. And then this can be anything you want. I could have named this user, I could have named this whatever. Then we set it to user. You could also create a session of, user logged in, and then you would do true. You could do like a lot of things. Like you can name it whatever you want. You can set it to whatever you want. In the end, you're going to need to cast it when you want to use it. So just keep that in mind. And then after the user logs in, we redirect to the dashboard. Now the dashboard is under the system master page, if you guys remember. In the system master page, if we go to the back end on the page load of the master page, we get the user, the logged in user, and then we cast the session of user. So if the user, if the session that we just set is null, then redirect them back to the login page because they're not actually logged in. They may be trying to access a dashboard page directly, which in that case it will have a null. They'll have a null page or a null session of user. Or they didn't log in correctly and we don't want to give them that access. So, but if they do have a user logged in, it will take them to the login page, or it'll keep them on this page that they requested. That's behind this master page. So let's demonstrate. I'm going to demonstrate how sessions can be used throughout different pages. So let's see the dashboard on the page load. Let's do user equals we have to cast it, so session, and then this has to be the same name. And then let's go to our order services page load. Do user equals user, and then session user. We'll set a breakpoint here. We'll set a breakpoint here. Then we'll play. So you'll see right now that it's trying to hit up our dashboard, but we're not logged in. So it kicked us back to the login screen. So let's log in. So now you can see that so after we logged in, when we click that login button, right here, it set our session of user. So this session was previously null, but then we set it to user. So now you guys can see that we're logged in, and it's trying to load this user. So we'll just step through it, and you can see that now we have the user that I logged in with, and now we're on the dashboard. So we logged in on the login.aspx page. That's where we initially grabbed this user, but because we put it in a session, we were able to transfer this session of the user over to this other dashboard page. And so you can see here that, we have a user. Great. Let's continue. And let's go to our order services page. So right now you see the user's null, but because the session lasts throughout the entire, all the pages throughout the entire application, it's gonna, once we step through this code, it's gonna assign that user to here. So you can see that now we're on a completely different page, but we still have access to our user that's logged in. So there you go. Now let's demonstrate the same, the same concept, but let's demonstrate it with a view state. So I will set a view state here on the dashboard. So view state, and then this can have the same name. It's a different way of storing it. So you can give it the same name. You know, there's a session of user. You can also have a view state of user. They're two different things. View state user equals, now let's assign this view the view state of user to our user. So here we'll see user view state user equals user. So let's set a breakpoint here. And then let's go to our orders services page and do the same thing. But now we're not going to actually be setting it. We're going to try and grab the view state user. And in this example, you guys will see that it's null and that it doesn't exist. Because as I said in my presentation, view state is page specific, only lasts for one page and then it dies. Whereas a session lasts for the entire application unless one of the three conditions happen that kill the session. So let's go ahead, save, and then run. It's loading up. It's loading up the dashboard. Okay, yep. Okay. So let's log in. So now we are in our page load of the dashboard. So now it's trying to load up the dashboard page. So right now, user from the session was grabbed, and you can see that the user object is here, but view state right now is nothing. So we'll go ahead and we'll set the view state. And you can see that now view state actually does have something. There we go. And so now, since view state does have something, we're going to cast it to the type of user. We're going to set our view state user. So here in this dashboard page, you can see because this view state user was assigned, that means that we did have something in our user view state. And what this means is now we can use this view state throughout this entire page. Now let's continue. Let's go back to our page. And let's go to order services and try to use that same view state of user and see what happens. So here you can see that the view state right now doesn't have anything in it, right? And that's because the view state of user didn't transfer from one page to the other because it can't do that. So you'll see that when we do this, our user here is null. Our view state user is null because view state of user did not exist. I would have had to have set it first specifically in this page for it to exist. Another thing I want to show you guys with this is let's go into the page source. See if we can find. Yeah. So like I said, when a view state gets saved, it saves a view state here. So the user object that I have saved into the view state for use throughout the entire page got saved here. So I don't know if it got saved. I think it got saved here in this view state. And you can see that it's just like a bunch of data. Now, like I mentioned, if you have a list of 1 million objects, this view state is going to get pretty large, and it's going to take the page a long time to load because it has to load all of this text within it. Keep in mind that a view state gets stored on the client side. So yeah, so keep in mind again, interfaces make your code unit testable. So you always want to have an interface with your repository and with your business logic layer, and it maintains that contract between your classes and the interfaces. Just makes it more maintainable and just better to read in general. Keeps that separation of layers. In week 9, I know that I said that that I mentioned in the presentation, HTTP verbs with web APIs. So in week 9, we will actually go over this in more detail, and we'll be using Postman to make requests into our application. So anyway, I hope that you guys found this useful. Hit like if you like the video, and subscribe if you'd like to be notified whenever new videos come out. Thanks. Have a good day. Bye.